Hello everyone. In this lesson we're going to cover the Pascal's principle. So let's understand its statement and explore the most amazing application it has in real life. Stay tuned until the end because we're going to solve a practical example step by step. According to Pascal's principle, a change in pressure applied to enclosed fluid is transmitted undiminished to all portions of the fluid and to the walls of its container. Pascal's principle is named after Blaise Pascal. He was a French mathematician, physicist, inventor, philosopher, writer, and Catholic theologian. But this principle is because of his works in physics. Basically, he's saying here that the pressure at a point in a fluid at rest is the same in all directions. You can make an experiment here. We can take this bulb and make some holes in different parts of this bulb that's full of water, okay, and apply some pressure on it. You'll notice that the water will leave this bulb here with the same pressure in all the holes. That's the Pascal's principle. Another thing that we can deduce from this principle is that the total pressure in a fluid is the sum of the pressures from different sources. So if we have a ball here and apply a force over an area, therefore a pressure on this side and another one on the other side, well, the total pressure inside here will be the sum of the pressures from the different sources, okay? And that's basically the Pascal's principle. Now let's go through some of the applications, okay? Mostly we apply Pascal's principle to hydraulic systems. Well, we have here a small hydraulic system. So we have two cylinders, okay, two pistons that are connected. This piston here has a small area, okay, A1, and we are applying a force here over this small area. Well, you can think that, well, if you apply force here, then this piston will go up. So this another piston with a larger area will go up due to the force that we apply here. Well, let's remember then that pressure is force over area, right? And we have for each side here, we have the corresponding pressure. So according to the Pascal's principle, the pressure of the fluid here, so you're applying some pressure here, and this pressure is transmitted through the entire fluid, and it's going to end here with the same pressure, okay? So the relation we have is that the pressure on 1 is the same as the pressure at 2. So if we consider that this pressure is F over A, we have this relation here. This is pretty useful, pretty interesting, okay? Because what matters here is not the amount of force or the area, okay, but this ratio here of force over area. So for a small area like this, we can apply a small force and we can multiply this force on the other side by increasing the area. So in order for these two sides of the equation to be the same, if we have a small area and a small force, and on this side here we have a large area, the force needs to be also a large to keep the same ratio on both sides, okay? This is the principle that we use in most of the hydraulic systems. Your car jack, for example, you have a small cylinder here where we apply a certain pressure, okay, with our hands, with our arms, and it multiplies the pressure to this bigger cylinder. So it has a bigger area, so the force over here will be greater. And that's also the same principle of the hydraulic steering system, okay, in some cars. Nowadays we have the electric steering wheel, right? But back in the day we had hydraulic steering systems. So note that we have small tubes here, okay, so small areas, and then it goes to a bigger cylinder with a bigger area. So all the heavy machinery, all the hydraulic heavy machinery that we have use this Pascal's principle to lift heavy things, okay? And that's also the same principle we have in those hydraulic press that we see those very pleasant videos, right? That's exactly the same principle. Let's go now through a problem. Okay, let's solve this problem here step by step. So we have a force of 100 newtons that is applied to the brake pedal, which acts on the pedal cylinder through a lever, right? A force F1 is exerted on this pedal cylinder right here, this small cylinder, and pressure created in the pedal cylinder is transmitted to four-wheel cylinders right here. So the pedal cylinder has a diameter of 0.5 centimeters, and each wheel cylinder has a diameter of 2.5 centimeters. We want to calculate the force F2 created at each of the wheel cylinders. Okay, so we are applying a force here on the pedal that's transmitted to the small cylinder and then to the bigger ones of the wheel, okay, the wheel cylinders. Alright, so first we need to calculate this force F1 here. Well, we can say that the torque at this position here needs to be the same of this one because we have an equilibrium, right? So the force applied on the pedal times this lever arm here is the same as the force that's applied on the cylinder times the lever arm over here. So we have that 100 times 0.2 meters, right, is F1 times 0.04 meters. Well, from here we can isolate F1 and find that this force here that's exerted on the pedal cylinder is 500 newtons. Alright? So see that we multiplied our force by 5 just adding this small lever here, right? Then we want to calculate force F2 for each wheel cylinder. Well, let's apply then the Pascal's principle and use this formula. So we have F1 over A1 equals F2 over A2. We can isolate F2, that's the thing we want to find. And well, the area for a cylinder, okay, it's PR squared. We have for 2, right? Very good. We can then just add the values. We have the diameters here. We can add the values for the radius, okay? And find that F2 is actually 1.25 times 10 to the 4th newtons. So see how much we multiply the force just by changing the size or the area that we apply this force, okay, using a fluid. So that's it for now. Hope you enjoyed and see you next time.
Physics can be easy. Subscribe to our channel and learn with the geeks.